is a type of transformation. So go back in your memory banks when we were doing transformations. So we did 3 kinds. What was the name of one of them? Reflection, rotation, translation. Perfect. And when we were doing any of them, did they ever change shape?
No.
Did they ever change side?
No.
And there was 2 different words, vocabulary words, that counted for meaning that they didn't change shape or size.
Was it like the rigid motion?
Rigid motion is one. Okay, what was the other one?
Isolation.
There you go, isometry. Perfect. So that was a transformation. That didn't change shape or size. Okay? All right, so a dilation is a transformation in which the figure changes shape but not, or changes size but not shape. So does that mean, the question is it then a rigid motion?
No.
No. Is it an isometry?
No.
No, because they basically mean the same thing, right? Okay, so the pre-image, what was the pre-image?
Transformation.
Yep, that was the image before the transformation. Okay. And the image of the dilation, okay, are the same shape. Okay, perfect. Scale factor. What's scale factor? It's the ratio, basically. The scale factor of the dilation is the same as scale factor of these similar figures. Okay? And a dilation with a center of dilation, C, and scale factor of N for a triangle is written like this. Okay? So that's your notation. So when I say, write me the notation for this dilation, you're going to write it like this. So it's going to be D for dilation, and then you have the scale factor, and then you have the center of dilation, and then you have the figure. Kind of running out of room now. Yeah.
I usually am lowercase, but
I don't know. That's a really good question. Center of dilation. I don't know. That's a really good question. Just the way they do it. Okay. If the scale factor is greater than 1, think about this, okay? So I have this triangle. If I'm going to make it a scale factor of 2, if it's greater than 1, is the dilation is going to be what? Nick, what do you think?
It's like going to, I don't.
The right, describe it.
It's going to go in size.
Go up or down in size?
Up.
Up in size, absolutely. When it's greater than 1, it's an enlargement. Okay, so if it's greater than 1, it's an enlargement. So if it's less than 1, it's a what?
Small
It goes smaller.
shrinkage.
That's exactly it. Or a reduction. Okay, so true or false? A dilation is an isometry.
False.
I heard both. What do you agree? One of the two. Yeah, nice try. False. Because did it change shape? No. Does it change size?
Yes.
Yes. So a dilation is never an isometry. Okay? All right. So here's the two things that we're going to do. Actually, we're going to do these two examples, and then I'll turn you loose, okay? All right, so we're going to graph the image and the dilation centered at the origin, okay? Not centered at the origin as one of your higher up learning targets. Remember, what did we do when we rotated not about the origin? What was the rule when we did that? It was about a point, right? But how do we solve for that? What do we do?
You do R, and then you do the you got to hit it, and then you do the point, and then you do the or
Kinda, you're missing. What? Remember how we subtracted out the point to get it back to the origin, and then we did the rotation, and then we added the point back in? That's the same thing that you're doing for the dilation. Okay, it's the exact same step, but that's a higher learning target. We'll do examples on that later. Okay, so let's graph our original. So A is going to be -3. Here's my origin. So 1, 2, 3, up 4. Okay, there's A. B is -2, 0. C is 1, 0. And D is 2, 3. What kind of shape do we have? Do I have any parallel lines? Mm-mm. So what's it going to be? Just a quadrilateral. Okay. All right. So we're doing it about the origin, so I don't have to do anything else with that. Now, to find your new coordinates, all you have to do is multiply your x and y coordinates to get the new one. So A prime is going to be -3 times 3/2 and 4 times 3/2. Okay? Because my scale factor is 3/2. First question, is it going to be bigger or smaller than the original?
Bigger.
Bigger, because 3/2 is greater than 1. Okay, so -3 times 3 is -9/2. And 4 times 3 is 12. 12 divided by 2 gives me 6. So my A prime is -9/2, 6. Okay, good so far? Alrighty, so let's do that for B. B is going to be -2 times 3/2. And, well, what's 0 times anything? So that's just going to be 0. So -2 times 3 gives me negative 6. Negative 6 divided by 2 is going to give me negative 3, 0. Everybody with me? Don't say sure. If you're not, stop me and tell me where. Justin, question.
Wait, what is that sort of other B?
Negative 2 times 3 halves.
Miss Martin,
Mm-hmm.
after the 3 halves for A, you didn't put like 4 right next to it, but for B, you put 0 right next to it.
Because 0 times the 3 halves is just going to give me 0, so I just didn't bother writing it.
Oh,
Because anything times 0 is, that's why. I shortcutted it. Okay? Good so far? Okay. C prime. What is 1/2 times, or 3 halves times 1? 3 halves. And then we're going to have 3 halves times 0. And so it's going to be 3 halves 0. All right. And finally, D, I have 2 times 3 halves and 3 times 3 halves. And that's going to give me 3 and 9 halves. Not difficult, just kind of putsy. Okay? All right, so let's plot these points. Negative 9 halves is going to be negative 4 1/2. So I'm just going to rough guess it, okay? So 1, 2, 3, negative 4 1/2 and up 6 is going to be about here. You with me?
Yeah.
Okay. B prime is negative 3, 0. Well, that's easy enough. That's right here. C prime is 3 1/2, so that's 1 1/2, 0. And D is over 3 and up 4 1/2. And there's my new figure.
So this is an enlargement.
So that one is an enlargement. How else could we tell it was an enlargement? Before we even graphed it, Zach. 3 1/2. Yeah, so 3 halves is greater than 1, so that means it's an enlargement. Beautiful. Easy peasy. Mhm. Okay. Let's look at the next one. I want to find the scale factor. Okay? Because I want to write the rule for the dilation. First question. A to A prime. We're going to say this is A, this one's B, this one's C. A to B. Is it a dilation? And what kind of transformation is it? It's a reflection. Okay, so A to B was a reflection. What was the line of reflection? There you go. X is equal to 1. Beautiful. Everybody remember that? Because this is my line of reflection. And what's my figure that I reflected? ABC. Perfect. See how much you guys remember? It was awesome. Okay. Now let's do from B to C. Okay. Is it bigger or smaller? So it's a dilation, right? Okay. So we need a capital D. The second thing in our notation is the scale is the scale factor, right? Okay, so how do you find the scale factor? Find the ratio of the corresponding sides. So my ratio, let's use B to C, just to see what it is. Which one do you want to be the corresponding side? Let's use the straight one up and down. How's that sound? So are those two my corresponding sides? Okay. So B is 2. C is 1, 2, 3, 4. So that's a scale factor of 1/2. Is that an enlargement or a reduction? 1/2.
Like going from B to C is an enlargement, but this is like it was like
But 1/2 would be a reduction, right? That makes it smaller. So how do I have to write my ratio to show it as an enlargement? 2/1. So I need to do my scale factor not as B over C, but as C over B, because then I would be 4:2, which would give me a scale factor of 2. So I blew it up 2 times. Does that make sense?
yeah.
Okay, so you kind of have to watch that one and just kind of look at it and go, oh, is this bigger or smaller? All right, so I have a dilation of 2, and we're going to do it about the origin. Perfect. All right, and that's just how you find your scale factor to do your notation. Okay, because right now we're not worrying about whether it's about the origin or not. All right, good?